In the previous video, we plotted the data in this cal2 list using the command date_list plot. And that's a specialized function. Let me remind you what cal2 had to look like. It had to have a date object followed by a number. So what's a more traditional way of plotting this sort of data? Well, let me show you how we can plot it using bar chart. And so first what I'm going to do is I'm going to get rid of these inside lists and only retain the numbers here, like this 59 and this 59. So here's one way to do that. I'm going to use the second type of iterator. And so for each x in cal2, so for example, the first x is going to be this first inside list. And let's replace that inside list with the second entry in it. Or if you want, replace that inside list with the last entry in it. They're the same thing since they're length 2 lists. So now instead of a list of lists, I have a list of numbers. And that's the kind of input that bar chart takes. So it doesn't look nearly as good as this top one, but at least you see that it's working and didn't give me an error. So how can I make it look a little better? Well, one reason I don't think it looks very good is because it's like zoomed out so far. So let's zoom in using plot range. And you should expect me to put in an X range and a Y range. But for bar chart, you don't actually have an X range. It's just one bar followed by another bar. So all I have to do is tell it the Y range. And I'm going to copy the Y range that was chosen automatically by Mathematica. So 56.5 to 59.5. So now they're looking a lot more similar. But notice how this one is reversed from this one. And why is that? Well, for date list plot, it automatically put the data into chronological order, whereas here it definitely doesn't do that. And if I remind myself what cal2 looked like, it was in reverse chronological order. It was starting in October and working its way to June. So how can I reverse that? Well, here's one way. I can do cal3 equals table. And I don't think there's a way to do this with the second type of iterator, so I'm going to have to use the first type of iterator. So give me the ith thing in cal2 for I from length of cal2 down to 1, and the increment is -1. And notice how now it starts in June and is working its way forward in time. And let me suppress the output with semicolon. There's also a much faster way to do this. So let me name it cal4. I could just do reverse cal2. Hey, that did the same thing. So, and there are pros and cons to these. The first one, it uses more basic functionality. The second one uses this special built-in function to Mathematica, reverse. So you can decide which of those you prefer. And they both give the same result. And so let's go up here and let's replace this with either cal3 or cal4. They're the same list. So now you can see they're looking very similar. So what's actually happening here? Let me show you what bar chart does. So if I do bar chart of, for example, 10 to 19, 5. And maybe here you can believe that there are no X ranges for these bar charts. Okay, it's just one bar after the next bar. And here it's made the bars a lot narrower because there's so many more of the bars. But the principle is exactly the same. It takes a list of numbers and then plots bars of those heights, like one right after the other. And if I wanted, I could add some color to this. So here's one way. I could go to color function. And now there are lots of different options. I've pulled up the Wolfram documentation page color schemes that goes over some of these options. And I'm going to use the one that's called Thermometer Colors over here. And if we go back to look at the documentation, we can see that blue corresponds to the earlier values and red corresponds to the later values. And that corresponds here to blue is where the y values are smaller, red is to where the y values are bigger. And just as an example of what this sort of color function looks like, so what if I wanted to reverse these colors? That's kind of a natural thing to want to do because this corresponds to what percentage of the vote is Biden getting in some simulation. And so it might make sense, since blue corresponds to Democrats and red corresponds to Republicans, might make sense to reverse these so that Biden getting a bigger percentage is colored in blue. So let me first show you what this thermometer colors really means. If I do ColorData, thermometer colors, okay, there's some function. And for example, if I type in 0.2, I get one of the earlier colors. If I get 0.9, I get one of the later colors. If I type in 1.5, I get a later color. If I type in 100, I get a later color. And so in fact, the only numbers that matter are from 0 to 1. And then for a function hue, it repeats. So like 1.3 is the same as 0.3. For this color data, it doesn't repeat. Just once it gets bigger than 1, it's always constant. So let me show you in a table. So let's use the first type of iterator. Let me show you color data of this value x, for x from 0 up to 2 going up by 0.1. So here's 0. Around here is probably where it gets to 1. And then it just stays constant once it gets to 1. Okay, and similarly, if we started at like -2, okay, the negative values are all the same, and it only starts changing once we get to 0. So that's how this function works. Let me copy and paste this. And so what if I want to reverse this? Well, let me call this, how about my color? So input is going to be x. And, well, how can I reverse numbers from 0 to 1? I want those to correspond to 1 to 0. So, for example, 0.2, suddenly I want that to correspond to 0.8. Or 0.25 should correspond to 0.75. Well, there's an easy way to do that. I can just use 1 minus x here. And so what if for my color function, I go up here and let's see, maybe I'll copy and paste it so that you can see both at the same time. So instead of using this thermometer colors, what if I use my color? And there you can see it's reversed the colors.